Hello, good morning, Calculus 1. I want to teach you about the chain rule. This is really important. I love this. When you're doing derivatives, we have something called the chain rule. And here it is. I'm going to try to explain it to you. I mean, it's just this one rule. What you need to do when you read this is understand that what we have here is f of g of x. So this is not a product. This is not a product. This is the f function, and what the input to the f function is this g function. So it's g of x inside f of x, and that's f of g of x. The word for that, it's a composition of two functions. One function is inside, g is inside of f. Anyway, when you want to do a derivative like that, here's how, this is what the rule says. You kind of work your way outside in. You take the derivative of f prime, with the g inside it. Then you're not done. Then you have to take the derivative of the g that was inside, and you kind of multiply it on like another link in the chain. If there's a function within a function within a function within a function, then the chain rule can get kind of lengthy. You keep multiplying, but you keep doing the derivative of the inside, the derivative inside that, the derivative inside that. I need to show you an example. So we haven't done any of these yet. We've learned our basic power rules and a lot of our basic rules, and then we did products and quotients, but we haven't done any of these. So let's try this. So if I have a function, 6x plus 1 to the 9th power, I can handle this. I see a function within a function. I definitely see a chain rule going on here. I think what I have is something to the 9th. And sometimes we call that u, but I don't want to go through the steps of calling it u. But it's like a u to the 9th, something to the 9th. And to do that derivative, of course, you bring the 9 down. The derivative is, you bring the 9 down, and then that thing is raised to the 8th. So we just did a power rule on that. That's awesome. But that thing inside there, that is a g of x, and it's a function in itself, and I need to do its derivative according to the chain rule. At the end of work, you work your way outside in. At the end of the power rule, we have to do the derivative of the 6x plus 1. And the derivative of the 6x plus 1 is a 6. So sometimes I say the chain rule spits out a 6. That's what I say. But it makes sense to me. That's the derivative of the inside part. And that's it. This wasn't a product rule. It was a power rule, but it's got the chain rule. It's a classic chain rule. By the way, we do like to clean these up at the end, so I would bring the 6, multiply it by the 9, and call it 54, 6x plus 1 to the 8th. And that's it. That's clean. Here, let's try another one. If I have, I'll call this f of x, and I'll call it 6 cosine of 4x. So this is interesting. We've never done any like this. We've done cosine. Everybody knows how to do the derivative of cosine of x. Cosine of x, the derivative of cosine of x is negative sine x. Got that memorized. But when there's more to the x, when there's something within the cosine function, so the cosine function has a little function inside it. The cosine function has a little function inside it called 4x. So this is definitely a chain rule situation. It's easy though. Here we go. The derivative is, now by the way, this 6 multiplied out front, we had that rule that says we can just slide past that 6. Now I'm doing the derivative of cosine 4x. What's the derivative of cosine of anything? Negative sine. So it's a negative sine. I'll just put negative sine of 4x. You know, it is multiplied by that 6. It's not subtracted from that 6, so we'll fix that in a second. But to finish the chain rule now, we did the derivative of cosine is negative sine. I have to do the little derivative of the little 4x. What's the derivative of a little 4x? 4. Chain rule spits out a 4. And so the answer is negative 24. I put the negative and the 4 and the 6, multiply all that out front. Negative 24 sine 4x. That's the derivative. Let's do another example. Here's a function. What is the derivative of e to the negative x? Well, we learned the derivative of an e function is our easiest one. The derivative of an e function is just himself. So when I apply the rule for the e function, the derivative of the e function is just e to the negative x. But this one has a little chain rule. I need to do the derivative of the little function inside that e function. The function inside that e function is the negative x. I need to do the derivative of the negative x. That's just a negative 1. So the chain rule spits out a negative 1. It's multiplied on the end. That's what it is. That's the derivative of the inside. That's the inside function to the e function. This was the inside function to the cosine function. So the derivative of that was a negative 1, so there it is, negative e to the negative x. Hey, what if you want to do a second derivative? Let's do a second derivative. You slip past the negative sign, you take the derivative of the e function, that's just himself. The chain rule says you have to do the derivative of the negative x, which spits out another negative sign. If it spits out another negative sign and it's multiplied there, it's going to make it positive. So now we're back to positive e to the negative x. Whatever. So that's a few good examples to get us started. But you can use the chain rule. You know, these rules now, by the way, we're done with our rules. So kind of, we got all our basic rules. We got the product rule, the quotient rule, now the chain rule. We've got a lot of basic rules. Now, they're not always, these rules aren't mutually exclusive. You don't just use one or the other. Sometimes they're used together. I mean, a lot of times there's products and quotient rules with chain rules inside them. So, like this. Here's a function, e to the 2x cosine 4x. Let's take this derivative, please. Let's take this derivative, please. And overall, what I see, first of all, is a product rule. I mean, that's definitely the product of two functions. When I go to do the derivative, you do a product rule, you do the derivative of the first, you write down the second. When you go to do the derivative of the first, if you need to do a chain rule, you need to do a chain rule. When you go to do the derivative of the second, you might have to do a chain rule. So let's see how this works. The derivative of the first, that's just himself. Oh, but the chain rule says you have to multiply by the derivative of the 2x, which spits out a 2. So that was the derivative of the first involving a chain rule. Now we write down the second, plus, now we write down the first, and now we take the derivative of the second. We're taking the derivative of cosine. The derivative of cosine is multiplied here. It's a negative sine 4x. But the chain rule says you have to do the derivative of the 4x. So that spits out a 4. Sorry, I'm getting skinny here. It spits out a multiplied 4. Let's clean this up just a little. We're done. We're finished. We did a product rule with a couple of chain rules inside there. I would call that a 2 e to the 2x cosine 4x. And I would slide the negative sign and the 4 out front, negative 4 e to the 2x sine 4x. That's pretty clean. You may see somebody decide to factor out this term and this term. What do they have in common? You could factor out a 2 e to the 2x. That would leave me with a cosine 4x, a cosine of 4x minus, if I factored out a 2 e to the 2x, I'm left with a 2 sine 4x. So either of these, I think, is a pretty clean derivative. But that was a product rule with a chain rule inside. Let's try another one. This is one of my favorite problems here. This is one of my favorites, and the favorite part is kind of cleaning this up here. Let's work on this. Y is 6x squared times the square root of 5x plus 1. All right, so this is a classic problem. First of all, it's a product rule. Also, first of all, maybe we want to rewrite it. Let's just rewrite it. That's a 6x squared, and that's 5x plus 1 to the half. Of course, square root can be written as the half power. We learned that. All right, well then I see this as a product rule. That's definitely a product rule, and there might be a little chain rule action going on in there. Let's see, here we go. I want to do the derivative, and I want to do a product rule. The derivative of the first, the derivative of the 6x squared is a 12x. Write down the second, 5x plus 1 to the half, plus, write down the first, that's my 6x squared. And now I'm taking the derivative of that second part, I'm taking the derivative of this 5x plus 1 to the half. It's not too hard, it's a little power rule, but it's got something inside it. It's a little chain rule. I think at the end it's going to spit out a 5. Here we go. It's a 1/2, 5x plus 1, subtract 1, and you get negative a half. And you're not finished. A lot of students forget this. They forget the chain rule. You did the power rule beautifully, and don't forget you have to do the derivative of the inside. That's what the chain rule says. And the derivative of the inside is just a 5. So to me it spits out a 5. Cool. Guess what? We're done with the derivative. We did it beautifully. Nice product rule, a little chain rule action right there at the end. We're done. We do like to clean these up, and this is something maybe new to you. I want to teach you how to clean this up the most efficient way. When I see these, I see some stuff you can factor out, and I don't want to get, you might see a lot of things you can factor out, but the main thing I think that might be new to you is there's a 5x plus 1 to the half, and there's a 5x plus 1 to the negative half, and I like to factor out the one that's to the lowest power. Quick explanation. When you have this, what do you factor out? You factor out the x squared, and you're left with 1 plus x. You factor out the one with the lowest power. That's what they have in common, and you factor out the one with the lowest power. So that's what I'm going to do with this 5x plus 1. I'm going to factor out the 5x plus 1 to the negative a half, because that's the lowest power. Now, I know there's some other stuff I could factor out. Let's just not do that right now. Let's just focus on one thing at a time. I'm factoring out the 5x plus 1 to the negative a half. Let's see. So what's left right here? Well, the 12x is left, multiplied by, watch this, 5x plus 1 to the first. It's usually to the first, because you just factored 5x plus 1 to the negative a half out of 5x plus 1 to the positive a half. And so what you're left with is 5x plus 1 to the first. You could check it by distributing it back through. Distribute it back through, and you would add exponents, and you would get this. So it's 5x plus 1 to the first. You know, when it's to the first, you don't have to write that, but I'm a teacher. I try to explain things. But that's to the first. Plus, what's left over here? Well, this dude is totally gone. We factored him out. 5x plus 1 to the negative half is factored out. So all I'm left with is the 6x squared times a half times a 5. That's a 3 times, that's 15x squared. That's cool. And what's beautiful about that is what's left usually cleans up pretty well. If you distribute what's left, that's a 60x squared plus 12x plus a 15x squared. That's a 75x squared plus a 12x. So that's what's left. This is sitting out front. And that's fairly cleaned up, to tell you the truth. Sometimes we struggle typing these answers in and you know, what's acceptable. But that was pretty cool. What I wanted to really teach you was a chain rule, a product rule with a chain rule inside there. But I wanted to teach you this cleaning up move, this algebra. This was algebra that I just taught you. If I can factor a little more, and maybe that's considered a little cleaner here. Let's see. What else can I factor out? The 5x plus 1 is out here to the negative a half. I think I could factor out an x, and maybe a 3. I think a 3. I could factor out a 3x. That leaves me with 25x plus 4. All right. All right, so that's an answer. So that's an answer. That's an answer. Watch this. You might, because this is to the negative a half, maybe you want to move it to the denominator. So here's another answer. 3x times this 25x plus 4 all over this guy in the denominator, and maybe I could write him as a square root. The square root of 5x plus 1. So maybe that's a final cleaned up version, but I kind of like either one of these, to tell you the truth. They work for our purposes. All right, you learned about the chain rule, and then we got kind of advanced there kind of quickly. So thank you. Keep trying. Do some homework.